This is the fourth video in the series, and here we are going to look at equilibrium applications. And in these, we are going to solve simple beams. Next video will be for combined beams. Okay. Now, what is a beam? What is a beam? Beam, you can see in buildings, in bridges, all over the place. But for our purpose, in this given idealized problem, beam is a line AB, a dark line, a structural member, you can say. And our objective is to find, a question is determine the support reactions for the following beam. Now this beam is supported at A and B by what is called hinge at A and B as roller. Now these are the symbols. This is a symbol for hinge, this is a symbol for roller. Now this beam is subjected to a vertical load of 1000 Newton and anti-clockwise moment of 500 Newton meter. Now you see the beam is supposed to be in equilibrium. Obviously it doesn't move or rotate, so it is in equilibrium. And this is a typical problem of beam reaction, the application of the non-concurrent coplanar force system. Now the steps are like this. First, we replace the supports by appropriate reactions like this. Hinge gives us two reactions, HAVA. Roller gives us one reaction, VB. This is clarified in video 3 about the support reaction. One may want to look at that video. Okay. Now we are very clear on what's supposed to be happening. This beam AB is subjected to 1000 Newton load, 500 Newton meter moment, reaction force HA, reaction force VA, and reaction force VB. And all these together are keeping the beam in equilibrium. It means all these forces and moment together should obey our three equilibrium equations, that is sigma fx0, sigma fy0, sigma m0. These equilibrium equations are explained in video 3. We will now use them. So I just keep writing these three equilibrium equations. First equation, sigma fx, that should be equal to 0. So I sum up all the forces in horizontal direction. So only force is HA, and that is equal to 0. Sigma Fy, what I do is I add up all the forces in vertical directions, that is VA, VB, and 1000. 1000 is downward, so negative, and that should be equal to 0. And the last equilibrium equation, you can take moment about any point and equate it to 0. We have chosen point A, and we have taken moment of all these forces about A. HAVA pass through point A, don't give any moment. So I have VB into 5, 3 plus 2, 5. Sign is positive because I am taking anti-clockwise as positive. Then 1000 into 3, that is negative. And plus this anti-clockwise moment of 500 Newton meter. Now you saw here three equations, here three unknowns, HA, VA, and VB. And so we can work out support reaction as required in the problem. Now last equation itself gives us VB very easily. That's 500. If you put this VB in the second equation, you will get VA as 500, and HA we already worked out. So we have worked out all three reactions as required in the problem by using fundamental equations of equilibrium for coplanar non-concurrent forces, and we have applied them to this beam problem. Okay, look at next problem. Here, the loading on the beam AB is quite complicated. You know, there is uniformly distributed load and there are trapezoid loads. So we have looked at this loading in this manner, as if this one is throughout and then there are these triangular loads. Now, we are going to put equivalent of all these loads. See, and we are going to replace this support by appropriate reactions. So we have done that, HA, VA, VB, and in place of this uniformly distributed load, we have put 10 kilonewton load. See, it was 1 kilonewton per meter over 10 meters, magnitude is 10, and acting at the center of 10, that is 5. Now similar thing we are going to do for this triangle. See, this triangle, or this vertical distance is not 2 now, because 1 we already taken care, so it is 1. So it is 1 into 4 by 2, and here it is 4 into 3 by 2. So accordingly, we have put here reaction 2, and we have put here reaction, the load 6 and 2, and the distances are at the centroids of those respective triangles. So in other words, we have reduced that complicated loading system into 3 vertical loads, and now we are going to simply apply sigma fx0, sigma fy0, sigma m0 to these loads and the reactions. So sigma fx0 again simply gives me HA equal to 0. Sigma fy0 goes like this: VA plus VB minus 10, 2 and 6. And sigma m about moment, I'm taking again moment about A. Sigma m equal to 0 tells me VB into whole distance 10, then 6 into this distance 9, and 2 into this distance 4.33, and 10 into distance 5. See, the last equation will give me VB, and if I put it in the sigma fy equation, I get VA, and HA we have already worked out. So we have again worked out all the support reaction by using equilibrium equations and applying it to this beam. This problem again similar. Remove the supports by appropriate reactions, and inclined loads are converted into horizontal and vertical, and then all we have done is written sigma fx, all the forces in horizontal direction, HA 8 cos 30 and minus 16 cos 50 and minus 20 cos 40, sigma fy VA plus VB plus 20 sin minus 16 sin 50 plus 20 sin 40 this one plus 8 sin 30 this one equal to 0, and then taking moment about point A equal to 0, I get VB into 9, 16 sin 50 into 6, 8 cos 60, see this 8 cos 60 to height 1 and 20 cos 40 this into height 3 equal to 0. 3 equations, 3 unknowns, so you are able to solve it. VB is 3.83, VA is 8.43 and HA is 18.68. Minus sign indicates that what HA we had assumed as towards right, I mean VA, VA minus sign indicates what VA we had assumed up is actually it is down. It is down. That's all it means. And we have worked out reactions as required in the problem.